Scientific notation. So, what is scientific notation? Great question. Glad I asked it. Scientific notation is a way to write very large or very small numbers more easily. Scientific notation takes up less space. So let's take a look at an example of a number that would really fit scientific notation. This is the speed of light in a vacuum. A vacuum would be space. 300 million meters per second. It's a very large number. To make it easier to work with, we can put it in scientific notation, and it would look like this. Smaller, right? And that's better in a lot of ways. So to do that, we have to first identify the coefficient. That's the first number that you see, the 3.0. The rule is that number has to be greater than or equal to 1. But it also has to be less than 10. The next number is called the base. And that is always 10 when it comes to scientific notation. You may see it written as an E on a graphing calculator or somewhere else in a textbook, but the E is equal to 10. The number that the 10 is raised to is the exponent. That's the third number. That's the power that we're raising 10 to. Basically how many zeros you're going to add or subtract from your number. Let's try an example. So here's 123 billion as a number. Let's put it in scientific notation. Our first step would be to find the coefficient. And that's going to be a decimal place between the first digit and the second digit. So that would be right here. All right. So now we've identified the coefficient. And as a result, we can shorten the number and figure out how many zeros we need to add. To do that, we have to find the places from where we now have the decimal to where it was originally. So now we need to count. It was here, so we got to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. A total of 11 places. And we move the decimal place to the left, right? So as a result of those 11 decimal places, that's what we raise our power of 10 to. So in the end, our number looks like this. 1.23 times 10 to the 11th. Okay? I know it seems easy because I just did it with you. So let's try a tougher example. What if we wanted to take a small number and put it into scientific notation? 0.000016 seconds into scientific notation would follow this procedure. So again, same as before, we have to find our coefficient. And now we're working with the back end of the number. Our coefficient is going to be here. And our decimal place is between the last two digits. Notice it's less than 10, but greater than 1. Greater than or equal to 1. Okay? That being said, we need to figure out how many places we've moved the decimal. So that if you remember, the decimal place was here. Now it's here. So how many spaces did we move it? 1, 2, 3, 4, 5, 6. And we moved it to the right. So that's a total of 6 decimal places. That means when we raise it to a power of 10, we have to put the number 6. The only difference is because we went to the right and not to the left, it would be a negative exponent. So our number, in this case, would look like this. 1.6 times 10 to the negative 6. All right, so what if we had a number in scientific notation? This we'll encounter often, and we now have to take it out. How do we take that number out? Well, first, we have to move the decimal place, the number of digits that are indicated by the power of 10. This number, it was 6. So now we have to move the decimal place 6 spaces. So it's here, 1, 2, 3, 4, 5, 6. And we're going to fill in with zeros to get our new number. What that looks like from where we were is this. Because it was a positive exponent, we went to the right in this case. So when you're taking a number out of scientific notation, if you have a positive power, you go to the right. If we were dealing with negative exponent, we would have gone to the left. The decimal place would have went to the left. It's the opposite of when you're putting a number into scientific notation. All right? So we fill in the spaces with zeros, and then we add commas. We wind up with 1,450,000. Let's try that same procedure with another number. Okay? So we have a number 92 million, and we want to put it into scientific notation. How do we do that? First, we identify the coefficient. So we're looking here. The decimal place goes between the 9 and the 2, so we wind up with 9.2. Our next step is to figure out, all right, the decimal was here, now I moved it here. How many spaces did I move it? 1, 2, 3, 4, 5, 6, 7. Total of 7 spaces to the left. And because we're putting this number into scientific notation and we move to the left, it's going to be a positive exponent. So we know it's 9.2 times 10 to the positive 7th power. Let's try another one. So now we have 0.065, and we want to put this number into scientific notation. Same rules apply. First, identify the coefficient. It's right here. All right, our decimal place would go between the 6 and a 5. So we have 6.5. We have to figure out how many decimal places we moved our decimal. 1, 2. But we moved it to the right. And because we moved it to the right, that's a negative exponent. So now we have 6.2 times 10 to the negative 2 power. All right. I know you're going to need more practice with that, and we will. Let's try the example of taking a number out of scientific notation. So 4.5 times 10 to the 9th. If we're taking it out of scientific notation, we're going to first drop this part and just deal with the 4.5. We know that we have to move the decimal place 9 spaces. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill in with zeros. And I wind up with a number that looks like this. Get some commas. 4,500,000,000. How did I know to move my decimal place to the right? How did I know? Well, because I'm taking it out of scientific notation and I had a positive exponent, when I'm taking it out, I move to the right. I'm making the number bigger. Let's try one more example. We have 1.06 times 10 to the negative 9th, and we want to take this out of scientific notation. How do we do that? Same rules apply that we just used. I'm going to drop this part and have 1.06, and now I have a negative exponent. So in the previous example, we had a positive 1 and we went to the right. Well, now we have a negative 1, so we're going to go to the left. So our 1.06, this decimal is going to go 9 spaces to the left. I'm going to redraw that so I have enough room. So 1.06, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my new decimal point. I'm going to fill in with zeros. And then I wind up with a number that looks like this. And that's scientific notation. Okay? We're going to practice more in class when you come in on Tuesday. But rewatch this video if you need to a couple of times and make sure you complete the notes page that's attached to the Google Classroom underneath this video. Thanks for watching.